Okay, can you hear me? Yeah, I can hear myself, so I guess you can. So, hello everyone, thanks for coming on Sunday afternoon. I'm Jiří Stránský, and I will be talking about how we deploy Kubernetes cluster or OpenShift cluster for other purposes with TripleO. And it's not going to be too much focused on TripleO itself, not going to be too much focused on the Kubernetes itself, but mainly on the integration. We got 20 minutes, so it's going to be fairly high level. Yeah, so first, some basic introduction. I guess you probably know what Kubernetes is, but maybe you haven't heard of TripleO yet. So TripleO stands for OpenStack on OpenStack, and those are tools for deployment and management of OpenStack clouds. And it's called OpenStack on OpenStack because we try, whenever it makes at least a bit of sense, to use OpenStack's own tools to do the installation. So it has like a sort of interesting recursive architecture, which I'm not going to talk about, but there are talks from previous DevCons, so you can find it online if you're interested. And we've kept following users' requirements and demands. And over the time, we implemented a framework which is so generic that you can use it as a generic provisioning tool and generic installation tool. So one of the things that we're now looking into upstream is integration of container orchestration engines. So either Kubernetes, if you want to be really close to upstream and try new stuff, or OpenShift Origin if you want to be more geared towards production. And there are two important use cases for this. One of them is that installers for this kind of software, and it's not only container orchestration engines, but many installers of complex software, they sometimes assume that you already have your machines or your bare metals where you want to install provisioned and ready with your operating system. And if you have to prepare 100 machines like this, it's better to do it with some automated tool, and this is the part that TripleO can provide. So that's one of the ways this integration makes sense, to get bare metal management for installation of container orchestration engines or Ceph or things like this. The other use case is related to the fact that we already deploy OpenStack in containers for benefits with updates, etc. And so we have a cluster of machines. To manage containers on those machines, we had to build a little tools around those around Docker. And the logical next step would be to replace those in-house custom tools with something that's used in the whole community, like Kubernetes or OpenShift Origin, so that we don't have to roll so much of our own code, and we can benefit on what others are building already. So the first challenge that we actually talked about in the team was we're integrating a complex piece of software, and so should we use a custom method that we already have implemented in TripleO, that because we are an OpenStack installer, we didn't just integrate another OpenStack installer because we're it. So we have a custom method for deploying software, and there was one of the options here that we just use our classic TripleO deployment mechanisms and write plugins for Kubernetes and OpenShift Origin. And the other option was that we're going to just take an existing installer, like KubeSpray for Kubernetes or OpenShift Ansible for OpenShift Origin, and figure out how to make those fairly complex installers work together well. And the solution we picked, we already had an inspiration because we tried both of those approaches with Ceph. Initially, when we started deploying Ceph as part of the OpenStack deployments, TripleO only had this custom way of deploying software. So we wrote our custom Puppet manifest that deployed Ceph. And then we progressed further, and we decided to integrate Ceph Ansible And I think that proved over time more sustainable. And yeah, we didn't, so for example, with the custom solution, we always had to keep looking at what the Ceph community is doing and match those changes in our solution. After we implemented or like integrated Ceph Ansible, we just got all the benefits and changes for free, essentially, because the Ceph community was already doing that work. So yeah, I would say this is not a silver bullet, but as the complexity of the software that you're trying to integrate into your project is growing, it's probably more and more worth to look at some existing solutions for installation, because the integration is probably, like it's difficult always, but you're probably going to benefit more from it than you're going to lose. So that's our decision to get Kubernetes into TripleO. We're just going to use another installer embedded into TripleO, and that way we get best practices for free, HA for free, proper networking configuration. We're just going to benefit from what the community is already doing. Now, once we decided this, there was another sort of point where we had to make an important decision, and that was, so TripleO in the next generation deployment framework that we're building, which is not yet part of the release, but it's already, so it is part of the release. It's not default yet. It's probably going to be default soon. We are all Ansible based, sort of, and the embedded installers that we are trying to embed, like Ceph Ansible, OpenShift Ansible, and Kubespray, they are also Ansible based. So the one way we could do the integration is just to import the playbook from the external installer. The other way would be to run it as a sub-process. We actually had quite a lot of discussion around this, because it's not entirely obvious what you should pick because of the benefits and drawbacks. So with import playbook, you can sort of obviously integrate only Ansible embedded installers. With the shell method, you can shell out to any process. There's also an important thing about inventory and variables and possible tags that you're using with your Ansible playbooks. And that's the fact that if you do the import playbook, you just you sort of get, again, things for free, sort of, because the inventory, for example, that you used for the outer playbook is going to get transferred to the inner playbook, your variables as well, etc. And with the shell method, you must generate from your outer Ansible playbook. You just run a task that generates another inventory. You're going to reuse some of those hosts from your outer inventory and generate a new inventory from it that gets passed to the inner playbook. So it's sort of more work, but you get more control and better separation in return. And the last important point that's worth mentioning is the logging, which, if in case you do import playbook, you get the tasks neatly reported. Like each task in the embedded installer appears in the log progressively, whereas if you use the shell method, you just run the whole embedded installer as a single task in the outer playbook, and you get the whole output as a really long log output. So we decided to go with the shell option, so sort of using Ansible around Ansible. As I mentioned, it's really nice, clean interface, separation of namespaces. It doesn't, you cannot just by accident export some variable in the outer playbook that's gonna automatically get picked up by the inner playbook and cause some conflict. It's versatile, not limited to Ansible, but the problem is that there is no progressive logging. So if the inner playbook runs for, say, 30 minutes or more, then the operator will not know, like, is it stuck or is it doing something? So that's a problem. So yeah, as I mentioned, the outer Ansible process, the way it's interfacing with the inner Ansible, it generates a bunch of files, variables, host groups, host variables, reusing what we had on the outer layer, but letting us keep in control of what you want to transfer or what you want to isolate. Then we generate another playbook, actually, which can take off handling prerequisites. For example, for OpenShift Ansible, we had to do some network manager configuration because it just expected it to be in a different state than we use it by default in TripleO. And then we import the playbook from the external embedded installer and run Ansible as a sub-process. And so yeah, we don't have any experience with integrating non-Ansible installers so far, but it would be fairly similar, just you would generate probably different files and execute it in a different way. The drawback I mentioned is progressive logging. So far, being it very early in the iteration, we have a very naive solution, which is just to use the T utility to output the log into a file as well as into the outer Ansible. And we just print in the outer Ansible where operator can find the log file if they want to look. So if they feel like, I don't know if it's stuck or if it's doing something, they can go look at the file where it appears just task by task as they are used to from running Ansible. We could improve on this in the future, possibly by integrating with something like AWX or ERA, which would be collecting those logs from the inner playbook run. Or we could use some other way we could use the Ansible callbacks in some custom way. This is yet to be investigated and done. So far we have just the naive solution. So to put this into a greater context of TripleO deployment workflow, what you see is the full, it's simplified, but the main parts are there. It's this full deployment workflow of the TripleO tooling. So what we first do is that we create an OpenStack heat stack. Heat is like a resource orchestrator. In OpenStack, you can write your definition, and it's going to call APIs and create resources like servers or networks, and it's going to keep information about those. And this just installs the bare operating system on the machines, and we don't yet run any software configuration. From that heat stack, we take outputs, and from them we generate Ansible playbooks, and that gives us the outer encapsulating Ansible playbook, and we execute it. Inside the outer Ansible playbook, there's a step loop. We have currently 6 steps. The tasks that you see that run on the diagram on the management host, those are the tasks that we use. They are newly added, and we use them for running the external installers because they have full access to the overcloud, to the OpenStack or another cloud inventory. And then we run also tasks directly on those provisioned hosts. This is sort of a historical way because we previously used pool software config management, where all the machines would pull the config from the management machine, and then they would run locally the config management, like Puppet, which we used to use for this. And but we ran into some into race conditions quite often, and it seems that the push-based config management might be the way in the future. So we're sort of probably going to converge over time to the tasks run from the management host, which can access the whole inventory. And yeah, so we run this loop a few times. Like in step 1, we do NTP configuration, firewall configuration, just basic prerequisites. Then in step 2, we could deploy Kubernetes or OpenShift origin. And then in step 3, we could start using the Kubernetes to start deploying services on it, and go on and on like this, and maybe like have an OpenStack cloud based in containers on Kubernetes in the end. Actually, Flavio Percoco had a talk yesterday about how to deploy OpenStack in Kubernetes, and this is tightly connected to this. So yeah, that's the next step that we would do after having Kubernetes installed. This whole workflow runs in a Mistral tool, which is an OpenStack native workflow tool. And yeah, so we run into all that, and we get sort of OpenStack. Well, this was repurposed from OpenStack cloud to a Kubernetes cloud, so the machines have OpenStack names, but it's a 6-node Kubernetes cluster with 3 controllers in an HA way with networking configured. So to summarize, if you are going to be dealing with the same problems, maybe you are working on an umbrella installer as well. So if you need to embed complex software into your project, it's really nice to reuse existing installer, because you probably get more benefits than troubles from that in the long run. And it's really important that the installer that you're embedding has a clean and documented interface so that you can rely on it, that it doesn't change underneath you. So it needs to have some focus on backwards compatibility. And you, on your side, should have, on the side of the umbrella installer, should also have a clean interface so that you don't end up, as I said previously, leaking some variables into the inner installer. So that's all I have. And if you have some questions, we can progress to the questions. And here are also some links if you want to explore the code.
Do we have something to integrate Kubernetes with heat templates?
If we have something to integrate Kubernetes with heat templates. So this is actually done in heat templates. So we write the service definition for Kubernetes master and Kubernetes worker nodes in heat templates, and this generates the Ansible playbooks, and then we execute them. So the whole Kubernetes integration is about 200 lines of heat templates, which generate inventory and host variables, etc. Sure. Any other questions? Okay, if not, then thank you very much.